All right. Like remain, stop talking. Excellent. That's good. All right, so go ahead to now that we're going. Current unit lesson 6. We're gonna skip 5. There's not much there. And we're gonna talk about libraries. Libraries are pre-written code, or yeah, I mean it's all pre-written, but code that is useful in multiple applications. Okay. Functions, the key is that they are functions essentially that are sort of stored in another file or another folder or whatever sort of hierarchy organization system is being used. But you are still able to access them in whatever program you're working on. Okay. Ideally, they are functions that are useful in many apps. Like if you had a function, just think of the things that we've done a lot of. Returning a random item from a list. That seems like a function that we would use in almost every app that uses lists. It would be nice to have that in a collection of useful functions so you didn't have to write it every time. Or a function that finds the lowest number in a list or the highest number in a list. Okay. Or what else have we done a lot of? I don't know, that type of thing. Okay. In this first example, lesson 6, bubble 1, we have a program that uses these, well, you see here. Let's see if it works right away. I think it does work. Okay. If you go to functions in the toolbar, you'll see that there are now some very specific functions that are pre-written. Technically, everything in AppLab is a library. AppLab, all the blocks are pre-written functions for you, but that's neither here nor there. The key is that these extra functions are pre-written and they exist in the library that's already been imported for you. If you go to, please go to the settings gear above the toolbar and go to manage libraries. You will already have state library imported for your project. This is what, did everything go away? Okay. This is what the library looks like. Okay. These are just return functions that are in some other file that you can access them. If you were to copy these into the program, it would look really familiar. It would look like the functions that we're used to. Okay. And having them in the library is like the same as having them in your app, except you don't need to write them every time. Right. In this case, the library functions are highly specific to I'm having issues. Highly specific to this app, and whether or not these library functions are useful in a number of other applications would be debatable. I don't know how many states apps you're going to do, but if you wrote a library to be used with the states list, it would be useful in any app dealing with those lists. I'm having obvious issues right now. Let's just see if I can refresh it. And yeah, okay, we're good. So other key takeaways, when you mouse over the functions in the toolbar, you'll see that the documentation pops up. That's what this is called. And also like in the regular AppLab, when you go to examples, this is the AppLab documentation when it loads up. But the documentation for these functions, okay, it has the name of the function and it has the comments. Okay, a general explanation is the first thing. Then whatever parameters it's expecting and their data type and what's going to be returned in its data type. This is just the comments that you'll see are directly above each of the functions in the library. When you write your own library, your own series of functions that you think are generally useful, you will need to have comments. It will not let you upload functions to a library without having comments. Now, it doesn't check for them to be good comments, but you do have to have some sort of comment above the function, otherwise it won't let you do it. In our case, we are sticking with the first line general explanation. Then however many parameters there are go next and what the return is. Okay, all these functions are return functions and almost all of them will send a parameter. Okay, the random state function doesn't send a parameter, it just returns one of the states, one of the state's names. The other ones all return something based on the parameter, and they are useful throughout the app. Okay, are we supposed to do anything? I don't think we have any deliverables for this one, but we are all familiar with return functions, so this is actually easier because we don't even have to write the return functions. And bubble 2. Okay, this one, we have an app that will parse a string that whatever the user types in and return the Pig Latin variation of it. I'm not terribly concerned with the algorithm for Pig Latin, but you can see that when you go to functions, we have some built-in library functions that are all string functions or functions that are designed to receive a string and will return something based on it. Okay, first letter, whatever string you give it, it will return whatever's in the first position of that string. Okay, all but first does the opposite or the remainder, and so on. Checks for a val and returns true or false. And split string by space. Okay, append temp word, temp list, temp word. Splits a string into a list of words. Not really sure what that's doing there. String, append item. Yeah, so it just combines them to the one list. Okay, and what are we supposed to do here? Add a console log statement to test the rest of the functions. Try different several inputs. They're all used here, right? String first letter, all but first, has val. We have has val, and well, we are going to be in a situation where the project for this unit is just going to be a bunch of functions. They aren't going to have any application with them. They are designed, like I said, to be used elsewhere, but there is still programming to be done in the program code itself, or debugging and what have you. So let's just see what happens when we use some of these string functions. And I would say these are more generalized, more useful than the states one because they're designed to work with any string. So let's console log first letter, and I was going to let me throw that in there. Is this? Hold on a second. Should be able to throw this in. Strange. Why is it not? These are all returns. Strings first letter should get just a letter. Oh wait. This is strange. These are return functions. I should be able to add those. Just a second. What about for a variable? Something's acting strange. You should be able to put a return function inside of a console log. Yeah, I'm not terribly concerned with getting this test to work. Yeah. What happens if I just copy this? Like that is literally the thing I'm trying to do here. What happens? Well, something's going on with AppLab. Yeah, I think it might be broken. But either way, let's see what happens if we run the one that's there. Okay, console log, first letter, pizza, should return just a letter P. Great. All but first. I don't know. We don't need to go through all of them. Key is just having pre-made functions that can be applied however you need in the app. Okay, the check for understanding for this one should take you about 1 second, I think, if things work correctly. Okay, think about the application, so to speak, how you would use return functions, as I've explained over the last 10 minutes, and reflect, why is it important to use meaningful names for your functions in your library? It's pretty much the same explanation that we talk about forever about naming variables and function names and that sort of thing throughout. All right, when you're done with that, or how about just now, let's go to lesson 7, where we actually have some deliverables. It's definitely not nearly as exciting as making apps that have an input and an output, but it is a useful skill in that for real programming, like every programming language, everywhere, people are using libraries because it's just so useful, and mostly not libraries that they've written, libraries that other people have written that have super common and super useful functions ready to go, so that you don't have to write them in, like, vanilla JavaScript. Nobody does vanilla JavaScript. Everyone uses either jQuery or Angular or some other well, some of them are frameworks and some of them are libraries, and people struggle to tell the difference. But either way, having these pre-existing sets of code is super useful. Okay, so here we have another states list app. And does it already have? Okay, it already has the same library already loaded. Okay, our goal here is to pick a random state. Okay, we need to finish the new state function, pick a random state, and set that value or assign current state, whatever that result is, and then update the flag based on that. Okay, so we're going to need a random state function, but current state is our variable that is set up to hold whatever it is we pick at random. Okay, I wish I could shrink this one. So current state is going to be reassigned our pick a random state function, whatever the result is. And whenever you're working with return functions, you know, especially if you're accessing them through a library, always good to just as you go sort of pre-debug by doing console logs to make sure that things are getting there. And it is getting there. Okay, I'm sending the result of that to the debug console, and we are getting a random state, so it's working. Okay, all the syntax is good. We're good to go. Okay, so we've gotten a random state. Now we want to set the flag to that. So we just need a set property. Oh wait, we already have a set image. That'll work. The image is called flag image. There you go. And we want to set it to the state library state flag return function. And the state name we want to send it is whatever we got with current state. Okay, this return function is going to run and it will turn into one of the addresses for the state's flags. If you look at the documentation or the example, we've done this sort of thing before where it's looping through. Here we go. So it's looping through the state's names list, and if it matches it, it gets the flag at the same position in the flag list. Okay, that's what we spent the entire last unit on, traversing multiple lists, and it's doing that for you. Super easy. So now when you run it, it should work, hopefully. There you go, Maryland. And you have to spell it correctly. Yeah, anytime you have user putting in, isn't that Ohio? Utah. Anytime you have user typing things in, if what is going on? Guest button click, set property, if guest state equals current state. Oh, is it? It is case sensitive. Yeah, there we go. Just as a side note for user interface, user experience, having a drop down would probably be a much better app, but we're not worried about that right now. Or informing the user that they have to capitalize it correctly. But either way, the key is we can access these return functions that were already written for us. Okay, bubble 2. So we have a cats library. And what's interesting about the way AppLab sets up the return, or not the return, the libraries, is that these libraries are doing the get columns for you. Okay, this get columns function, or get columns, you know, the dark green block is in the library, so you don't need to ever run the get column, assuming it's already there. Obviously you would need to have the table loaded up, so there's that. So we have a function or an app that's supposed to get a cat at random and then put up a picture of it and put the text there. Okay, obviously we're going to need the random breed function, but we need a container to hold it. And let's call it, how about randcat? It's as good a name as any. And we'll call the return function random breed. And let's console log it just to make sure. Console log randcat, and see if we get a random cat. Oh, it only works on. There we go. Okay, so it looks like we're getting random breed names in the debug console. Is this so good? Okay, so we can get rid of that console log. We want to set the image here. Okay, breed image. Okay, so this function receives the name of a breed as a string and returns the image URL for that breed. Okay, you can picture this function in your mind. Takes a string, sorts through the list of names, and if it finds a match, it gets the picture at the same position in the picture list. But it's doing it for us. So we just need to set image, and we don't even have the set image. Seems an oversight. Set property of cat image, set its image property to whatever the result of cat breed image is, and we want to send it whatever was randomly received, random cat. And if this runs, if this works, we should get a picture. There we go. And we want to also set the text, so we can just do a set text of breed name to a random cat, because we want the same one for all of those, which is why we had to put it in a variable instead of just calling it directly. Okay, if we just wanted a random image, we could call random cat breed inside of the parameter for it might not work because of the stuff there. Inside the parameter of breed image, which is all that's happening here. It's the same thing. But we can use random cat multiple places, the same random one each time, and it should work. Okay, let's go on to bubble 3. That's where we get some debugging. Excellent. All right, so your project for this unit is going to be to create your own library of functions that you think are useful. I'll give you some examples and some suggestions, but you're going to write the functions, and that's it. The final project for this is just a set of functions. There's no interface elements, there's no image or set text or anything like that. It's just a bunch of return functions written effectively and bug-free. You will have comments above. It will always be this format. An explanation. However many strings there are, whatever their the name of the string, their data type, and what it is, followed by return. Okay, this one has 3 parameters that it's expecting. Number is a number, low is a number, high is a number, and it returns a Boolean, a true-false situation. Okay, but you need some way to test your functions to pre-debug them, because you don't want to submit a library where things don't work because somebody using them wouldn't be able to change your library. They've uploaded or attached a pre-existing library. So the way that you do that, I mean, I guess you could make a separate project and import it and go back and forth, but you're going to do console log examples to test your functions before you ship them. And that's what's set up here. We have a function is even, anything mod 2 equaling 0 is even. Okay, the functions are expecting a parameter that is a number, and it's going to be called number, which is a little on the nose. And so is even, sending a 10, a 5, or -2. Those are all well, they're all correct, and the context for this is some of them are going to be wrong. So here, true, false, true. Okay, it returns a Boolean, even though it's doing arithmetic in here. It is asking, the double equals is asking the question and equates to either true or false, and that's what it's returning either true or false. Same thing for is odd, anything mod 2 with a 1 or -1. I guess if you do a negative number mod 2, n was odd, it would come out -1. But either way, is 10 odd? False. Is 5 odd true? Is -5 odd true? Great. Last one. The last one is called is between. And you can usually tell a return function that is going to return a Boolean because it's like is game over, is even. Like those are great function names if your goal is to send it, pass it some parameter and expecting a true false result. Okay, it reminds you how it's written. It's expecting something to happen and return true if you're answering that, you know, arbitrary question that you've written as the function name. But here we go. Is between is expecting 3 parameters. The number to be tested, called number. It's a number. And then 2 other parameters that are both numbers, which are the low end of the range, the high end of the range, and it returns either true or false. Is number between low and high. And if we check the example here, it says is 10 between 0 and 5 true? That is wrong. Is 10 between 5 and 10 true? That is wrong. Is 10 between 15 and 20 true? That is wrong. Let's figure out why it's wrong. Well, it's asking return if number is greater than the low end of the range or number is less than the higher of the range. Of any number and any range, every number is either above the low or below the high. In order to be in a range, it needs to be both above the low and below the high. So in order to fix this, this conditional needs to be an and. And then that way we should get all falses for the examples. So instead of true for all 3, we'll run it now, it should say false for all 3. Because 10 is not between 0 and 5. It's not between 5 and 10 because we are checking greater than, not greater than or equal to, and vice versa. And it's not between 10 and 15. So the whole point of this was running your function inside of your library, well, inside of your program code to test it before you ship it, since once it's a library and publish, you can't change it. I mean, you can unpublish it, change it, and republish it, but it's a lot easier to fix it at this state. All right, so this library is another string library. There are a lot of times apps when you're parsing strings where you'd want to check through a list of all letters. And there, you good? You have a problem? Okay, I'm happy to answer a question. Where I'll tell you, on several occasions, I've written out a list of all the letters. It doesn't take super long, but it's kind of tedious. And it would be nice to have a library that just would return all the letters. And you could use it in loops. You could use it in, I don't know, any sort of regular expression type of thing. And that's what we have here. We have some return functions that are not receiving any parameters. They're just shipping back an entire list of all upper, all lower, vowels lower, etc. And the main function here is get letters, and it's being sent 2 parameters: the letter type that's wanted and whether it's upper or lower. And then we have some console logs that are testing it. And if we run it as is, okay, all upper looks to be correct. Let's see if I can make this a little better. Seriously? I can't make that any bigger. All upper seems to work. All lower seems to work. Consonant upper is wrong, and consonant lower is wrong. Vowel upper is wrong, and vowel lower is undefined. So we can go look at our get letters function and see what's wrong. And here we have that format that I showed you before with the rock, paper, scissors with the nested conditional, where the top level conditional is letter type, either all, consonant, or really this one could be else, because although else if isn't bad, checking to see if the user sends like something misspelled or something else, or not the user, if the other programmer using this function sends something incorrect that doesn't match one of the three, they don't get sent back vowels. But either way, we have our nested conditional where we have our first thing, we're checking one of three, and then each other one is checking whether it's upper or not. Okay, the second parameter is expecting a Boolean. So when it's called all true would be all upper, all false would be all lower, etc. Okay, we know that all upper works and all lower works. So the condition inside of all works. Problem is consonants doesn't work. The reason why is because they're switched. First one is all upper. We want it to, consonant upper should return consonant upper, and the other one should return that. And for vowels, vowels upper should return vowels upper, and vice versa. The problem though is if we switch these, and if you have any ability to seek patterns, you'll see that it's still something wrong. And it's because we are just calling vowels upper. We're not calling return the result of vowels upper. These words are all sort of blurring together in my head at this point, but that's fine. Vowels upper sounds German. And so, yeah, there we go. Now it works. Key takeaways are debugging your program or debugging your library inside of the library to make sure it works. Okay. And bubble 5, we're almost done. You'll have plenty of time to be productive otherwise shortly. And bubble 5. Okay, program design as a simple list library, write test to make sure a function works, write the second two functions so they pass the written test. Okay, good. So we have a function fill that receives a length of the list you want it to be and the value that you want it to be filled with. And it says, okay, so we need to, first thing, we're going to test this one, write some tests for it. And then we need to solve these, fill, complete, reverse, and complete, multiply by, so that they work with the tested situation. Okay, first of all, we have a, it says value, but it doesn't have a data type, and I think it can be anything. I wonder if that's what star means. But there should be one other comment here that I'd like for you to add, and that is the return. And the data type that's returning is list, and it is a new list of a given length for the same. I guess the explanation is also what you would have for the comment there. Okay, so we want to test fill. So let's console log. Let's console log the function fill. And we want to send it two parameters. One is however many items we want of something, and the other is what we want in it. And we run now. Is it there? Yes. Okay, it's this first one. Made a list with 4 of that. Okay, I think it also works with a number. Yep. It would also work with empty strings. Oh no, we want let's do 6 empty string. I wonder if it will work with this. Yeah, it made an array of array. No, it doesn't actually. That doesn't work, but neither here nor there. We have a function that works. We wrote a test and the test worked. Okay. This is a medium useful function. I've used things like that before. So there's that. All right, so these, oh, that's what it is, right? 3 different tests. We just did that. Okay, so we do need to solve for these. Multiply 1, 2, and 3 by 2. Okay, so we are receiving a list. Let's write our comments. Okay, multiply every number in a list by multiply every number in a list by another given number. And the parameters we are expecting a list. Well, it's called list. The data type is list. A list of provided numbers. I don't know, we don't have to get too specific. And the other parameter is called number, and it's a number. And it is, I don't know, a number, whatever, doesn't matter. And we are returning, oh no, not actually the word return, still a comment. Return, we are returning a list of products. Is that what a multiplication gives you? Not some, right? List of products of multiple, I don't know, something like that. Sure. And so we are returning a return list. It's called return list. We want to go through each number in list, and we're doing something to a list, so we're almost definitely going to have a loop, and we are going to have a loop. And we want to do the loop, whatever list comes through, dot length number of times. And for each item, we want to append item. We want to add something to the return list. And we want to return the number in the list we're looking at, list at index I, times the other number that was sent. And then we'll return this. Okay, and let's see what happens when we run it. Multiply 1, 2, and 3 by 2 gives us 2, 4, and 6. Multiply 10, 20, and 30 by 5 gives us 50, 100, and 150. And multiply -1, -2, -3 by 3 gives us -3, -6, -9. Beautiful. Okay, I don't know how useful this function is, but there you go, it works. And okay, reverse. So we have a list or function that receives a list and goes through the original list and returns a list backwards. So we have a return list. So let's just go through, since we have append item, we're going to loop through. Well, we could go through the entire list and do insert item to the first position and keep going to the first, but it's easier just to go through the list backwards, which here is a completely another trick. I wonder how, I don't expect, App Lab expects teachers to teach looping through backwards. But here's the thing about looping through things backwards. We want to start with the last item. So I is going to be list.length -1. Okay. We want to make our counting variable be start at the last index in the list, which is list.length -1. And we want to keep going forward, or rather keep going towards the front of the list. And the way we do that is by doing I minus. That goes backwards. But when do we want it to stop? We want it to, or rather, how long do we want it to continue? So long as our counting variable is greater than or equal to 0. I can't imagine how you would know that so far, but this is how you loop through something backwards. You could see if we compared it to the original. Okay, we're still starting with our counting variable. Normally we start at 0, but here we're starting at the last one. And okay, so if we were going through, normally it would be list.length. Okay, you don't have to bring out the second one. I'm just showing you the comparison. So instead of starting at the first item in the list and going to the end of the list and going up by 1, we are starting at the end of the list. I is list.length -1, continuing so long as we are a positive or 0, because 0 is the first one, into index, and every time through the loop going backwards. Minus is backwards. Okay, I am actually curious how App Lab solved it. We'll take a look at the example solution. I doubt they use this. Okay, so we're going through the list backwards, and we can append item to the return list, whatever we're looking at, which is list index I. And return this return list. So if we run this, we want it to be reverse 1, 2, 3 should be 3, 2, 1, and this should be maybe, no, yes. Okay, so what happened? Append item, return list. Oh no, it's right. There's just no space in there. If we put a space here, it would, or better yet, a colon. And there you go, there it works. Okay, reverse 1, 2, 3, the result is 3, 2, 1, and reverse yes, no, maybe, maybe, no, yes. Okay, if you go further into computer science, you will see loops going backwards. Anytime you are removing items from a list, like going through a list, checking for something, and then removing them, you have to go backwards, because otherwise you will skip positions, because as soon as you remove something, the list shrinks to fill in. And so when you go to check the next one, you will have missed one to check. But if you go through backwards, it's fine. I actually am curious what App Lab or what code thinks is the best way to do this. And they do list multiple. Oh, they do it. I'm surprised. Yeah, they do have the same. Code.org does expect people to know how to do a reverse list or reverse loop. Okay, and I think that's it for this one. Let's take a look at the check for understanding and see if it's applicable to what we're doing. Okay, so good. We got some pseudocode for libraries. And let's see what we've got here. Okay, practice the following procedure. List contains a negative number. List contains a negative number. It should return true, otherwise return false. An error was made, written in the code, so the work intended. What line of code would need to be fixed? These are tough questions. I would say on the for real test questions that are like, what line of code needs to be changed, is sort of difficult, or at least it requires a pretty high programming ability to just look at something and see what's wrong with it. Either way, we have a function called check negative, and it receives a list as a parameter. And we have, okay, so that's the start and end of the function. Variable has negative gets true for each number in the list. If number is less than 0, has negative gets true, return has negative. Okay, we are checking to see if something is true. If you're checking to see if something is true at any point, you need to start out with it false, and then switch it to true if it happens. Because this function is starting with true, or starting with has negative is true, there's no scenario in which our list where it would return the list as false, or the result as false. Okay, so is 3 one of the options? Let's see if 3 is the correct option. Yay, the teacher got it right. Okay. Yeah. Like at this point, I really don't even know if that's a fair question for most of you. Like not having a chance to run it in App Lab just to look at the code and solve for it. We haven't done a lot of Boolean stuff and like checking things resulting true or false, but that sort of context or paradigm of having a variable, and here the variable has negative, starting, if you're checking for something, you would start with it as false, and then as soon as you got a true, you would switch it to true. That's a pretty common programming situation. Okay, so that's where we're going to stop for today. Yeah, that's it.